An IPv6 multicast address is super easy to recognize because it always begins with an FF. And that's because the first 8 bits in its 128-bit address are all ones. In the topology I'm showing you on screen, we've got a multicast address of FF04::10. And just like with an IPv4 multicast address, that is the identifier of a group. So I've got a video server with an IPv6 address of 2000::4, and it's sending traffic destined for that multicast address. So in this case, only PCs 1 and 2 receive that traffic. Then after those first 8 bits, which give us FF in hex, we've got 4 flag bits, 4 scope bits, and the remaining 112 bits are for the multicast group ID. Now let's consider those 4 flag bits. And the original intention of those flag bits was to describe how this multicast group is going to be used. And we call them the 0 RTP bits. And the 0 bit is always a 0, and for completion's sake, you might see it in some of the literature, I went ahead and showed you the original intent for the R, T, and P bits, but in modern multicast networks, the 0 bit, the R bit, and the P bit, they're always going to be zeros. The only bit that we really care about today is the T bit. And if the T bit is a 0, then we have a well-known group, something like FF02::2, that would represent all routers on a link local scope. That's a permanently assigned multicast address. Or if the T bit is a 1, then it's a dynamically assigned multicast address. Maybe it was dynamically assigned by an application or a user, but it's not one of those permanent well-known addresses. So if this multicast IP address is one of those well-known IP addresses, then all 4 of these flags are going to be 0. Or if it's a dynamically created multicast address, then these flags are going to be 0010. The T bit is going to be a 1. And next we have 4 scope bits. And the scope bits identify the scope, or how far this multicast address can be used. Maybe it's only valid on a local interface, in which case the scope value would be a 1 in hex, where those bits would be 0001. Or if the multicast address was usable on a local link, in other words, a network segment, then the scope value would be a 2 in hex, so the bits would be 0010. If the multicast address is valid for a specific site, then the value is 5. If it's valid within an organization, then it's an 8. Or if it's valid globally, then it's an E. Let me give you a couple of examples. If we have FF02::1, we're talking about all nodes, router or otherwise, that are in a link local scope, a network segment. Now notice how this plays out. We have the FF saying this is an IPv6 multicast address, and notice that the next hex digit is a 0. That means our 0, R, T, and P bits are all zeros. We say they're all going to be zeros except the T by default, and the T is going to be a 0 if it's a well-known address. And this is. Another well-known address for all routers in the link local scope also begins with FF02. The 0 because this is a well-known address, and the 2 because it's valid on the local link on this network segment. And that address is FF02::2, and all routers on a network segment, in other words, within a link local scope, they're going to belong to that multicast group. And that is a look at the structure of an IPv6 multicast address, which is easy to recognize because it always begins with an FF.